in this slideshow video, let's take a look at another, the third power rule. It's called the power of a quotient rule. So basically, it's just like the power of product for basically for any real number a. Let me get my pen going here. Freezing up. For any real number a over b. So this is only one term. Whole thing raised into an outer exponent on the outside. So rather than a times b, now I got a over b. Still one term in the parenthesis though. So again, being a power rule, parenthesis, outer exponent, we're going to let the outer exponent in, multiply all the exponent in the inside. Okay? So that's why coming out for this particular rule, I should get a to the n over b to the n. Well, you might ask, well, what can I subtract the exponent? Well, I cannot subtract the exponent because the bases are different. I can only use the quotient rule where we subtract the exponent if the bases are the same. Okay. There was something I meant to tell y'all before in the last video what the power rule is. Maybe it was maybe I did mention it was about negative exponent. I don't type in negative exponent very often because I normally turn them into a positive exponent first and then key it in the calculator. That's how I get 216. If I just type in 6 to the third power, it's 216. If I type in 6 to the negative 3 power and then convert it into a fraction, that will be 1 over 216. What that means is puts 216 in the denominator. Okay. So if you don't have, so if there's no negative exponent, we don't think about flipping, okay, to the other side of fraction. All right, so let's try these couple examples real quick. So I see a parenthesis and I see exponent on the outside, so that remind me of doing power rule. So I got two bases here, an x and a y. So my outer exponent 2 will distribute its power onto the exponent that are in the inside. That means my outer exponent will multiply all the exponent in the inside. So coming out of the parenthesis, let's multiply. I should get, all right, x to the 2 times 2, which is 4, over y to the 1 times 2, which is 2. And that's my answer right here. That's it. All right. Now, whenever there's numerical value involved, it's always trickier because students always forget the numerical value in the inside, okay, all being one term. I purposely write times so we can separate our bases, our factors. So there's a 3 on the top. There's a 3 to the first on top. There's an x to the first on top. In the bottom, there's a 4 to the first and y to the first. Okay, so I'm just drawing this arrow so you can see there's 4 different factors here, or 4 different bases. So when it comes to multiply the exponent, make sure the outer exponent multiply the exponent on top of the 3, top of the x, top of the 4, and top of the y. So coming out of parentheses, that should be 3 to the 1 times 3, which is 3, x to the 1 times 3, which is 3, over 4 to the 1 times 3 is 3, times y to the 1 times 3, which is 3. Okay, so since there's no bases that are the same top and bottom, or just on the top, just on the bottom, then there's no exponent to add or subtract. We're just going to go ahead and figure out our numerical value here. 3 to the third is 3 times 3 times 3, which is 27, times x to the third, over 4 to the third is 64, times y to the third power. So that will be my answer. Okay, and they cannot be reduced. Okay, because 3 and 4 cannot be reduced earlier. All right, that's all it is for the power rule of a quotient. Okay, all right, that will conclude this video. Thank you for watching.